Hi students, welcome to Sankalp Learning Classes. In this session, we'll be discussing the 5-mark question from the chapter Matrices. We have already discussed the important concepts as well as the MCQ questions and the 3-mark questions. So we'll directly go on to the first question. The first question is, if A equal to matrix -2, 4, 5, B equal to matrix 1, 3, -6, then verify that AB the whole transpose is equal to B transpose A transpose. All right, so you are given two matrices A and B. So A is a 3 by 1 matrix, right? It has 3 rows and only 1 column. And what about B matrix? It has 3 columns as well as 1 row. So it is a 1 by 3 matrix, which means this is a row matrix and this one is a column matrix. All right. So now what they have asked is that you have to verify the condition AB the whole transpose is B transpose A transpose. Okay, you have to check that result using the given matrices. All right. For that, first you have to find out AB, right? A into B. You have to find out A into B. So what is A into B? -2, 4, 5. Right. This one is A and this one is B. 1, 3, -6. 1, 3, -6. Right. Now you have to multiply the matrix A with matrix B. How will you multiply? First row into first column will give you the first element of the matrix multiplication, right? So this is our first row, right? This is our first row. This is our first column. Okay. So what you have to do? You have to multiply the first row, the element in the first row with the element in the first column. So -2 into 1. There is only one element in the row of A as well as in the column also. It contains only one element. So -2 into 1 will give you the first element, right? So -2 is the first element. Now, what about the second element? How will you find out the second element? Second element, you have to multiply the first row with the second second column, right? So -2 into 3. What is it? -6. Now what happens? You have to multiply -2 with this -6 also. So -6 means it is +12, right? So the third element is nothing but 12. Now what you have to do? You have to consider the second row. Okay, second row, first you have to multiply it with the first column, then second column, then third column, right? So first you consider the first column. Okay, so 4 into 1 is 4. Then 4 into 3 is 12. Then 4 into -6 is -24. Right? Now consider the third row. Third row with each column, right? Then you will get the third row of the matrix multiplication AB. Okay. So 5 into 1. 5 into 1 is 5. Now 5 into 3. 5 into 3 is 15. Right? 5 into -6. What is 5 into -6? -30. Okay. So this is our matrix. What is it? -2, -6, 12, then 4, 12, -24, 5, 15, -30. All right. Now what you have to do for the LHS, we need the AB, the whole transpose, right? So we have found out AB. Now we have to find out the transpose of that matrix. So how will you find out the transpose of a matrix? You have to rearrange the row as columns, right? So what is AB transpose? AB transpose is AB, the whole transpose. Okay, this one is equal to this is our first row, right? So I'm writing it as our first column. Okay, -2, -6, 12. Then this one is 4, 12, -24. Then 5, 15, -30. Okay, so this is AB transpose. Okay, now you have to consider the right side. What is the right side? It is A transpose and B transpose, right? A transpose and B transpose. So first you find out B transpose. What is B transpose? B was the matrix B I'm writing here. Matrix B was 1, 3, minus 6. 1, 3, minus 6. So you write this one as column. So 1, 3, minus 6. Okay. The first row is rearranged as column in order to get the transpose of that particular matrix. And what about A? Matrix A is nothing but minus 2, 4, 5. This was our matrix A. And what about A transpose? A transpose will be minus 2, 4, 5. Minus 2, 4, 5. Now you have to multiply B transpose A transpose. B transpose A transpose. That is 1, 3, minus 6 into minus 2, 4, 5. Minus 2, 4, 5. Alright. So here you have to multiply each element with each column. Then you will get the first element. So that is equal to, here you can see 1 into minus 2. Then you will get the first element. Then 1 into 4. That is the second element. Then 1 into 5. Okay. So likewise, we are going to multiply each element. So 1 into minus 2 is minus 2. 1 into 4 is 4. 1 into 5 is 5. 3 into minus 2 is minus 6. 3 into 4 is 12. And 3 into 5 is 15. Minus 6 into minus 2 is plus 12. Then minus 6 into 4 is minus 24. Then minus 6 into 5 is minus 30. Okay. So our matrix is minus 2, 4, 5, minus 6, 12, 15, 12, minus 24, minus 30. What was our AB the whole transpose? AB the whole transpose was also the same matrix. Alright. So this was our LHS. Right. And now we have got our RHS. Right. So we finally conclude that LHS is equal to RHS, which means the result is true. Which result is true? AB the whole transpose. AB the whole transpose is nothing but B transpose into A transpose. Okay. Now we are moving on to the second question. So the second question is also a verification. If A equal to matrix 1, 2, minus 3, 5, 0, 2, 1, minus 1, 1, and matrix B is equal to 3, minus 1, 2, 4, 2, 5, 2, 0, 3. And C equal to matrix 4, 1, 2, 0, 3, 2, 1, minus 2, 3. Then compute A plus B and B minus C. Also verify that A plus B minus C equal to A plus B minus C. Okay, so this is our second question. They have given you three matrices A, B, and C. You have to verify that A plus B minus C is equal to A plus B minus C. So what is it actually? In the LHS, first you have to find out B minus C. That is, you have to subtract the matrix C from B. Okay, then you have to add that particular result with the matrix A. So you'll get the left-hand side of the equation. All right. Now, what about the right-hand side? In the right-hand side, the difference is that first you have to find out A plus B. Okay, you have to do the operation within the bracket first. Then you have to do the operations outside the bracket. All right. So first you have to find out what is A plus B, and then you will get a matrix, right? If you add two matrices, you will get another matrix. And then you have to subtract the matrix C from that matrix. All right. That is RHS. So we can do it because A, B, and C are given there. Okay. So first of all, we can calculate here. It is A plus B, right? So we can calculate A plus B. Okay. So for that, I'm writing matrix A. Matrix A is equal to 1, 2, minus 3, 5, 0, 2, 1, minus 1, 1. Matrix B equal to 3, minus 1, 2, 4, 2, 5, and 2, 0, 3. So these are matrices A and B. Now we have to find out A plus B, right? How will you find out A plus B? You have to add these two matrices. How to add two matrices? You have to add the corresponding elements, right? So first element is obtained by adding the first element of each matrix, right? So 1 plus 3 is equal to 4. So 4 is our first element. Now 2 minus 1 is 1. Minus 3 plus 2 is minus 1. 5 minus 4 is 1. 0, I'm sorry, 5 plus 4 is 9. And then 1 plus 3 is 4. 2 minus 1 is 1. Minus 3 plus 2 is minus 1. All right. Now 0 plus 2 is 2. Then 2 plus 5 is 7. 1 plus 2, 3. Then minus 1. 1 plus 3 is 4. Okay. So our matrix is 4, 1 minus 1, 7. 3 minus 1, 4. Okay. Now, then you have to find out B minus C also. So you need the matrix C, right? So I'm writing C here. So C was 4, 1, 2, 0, 3, 2, 1, minus 2, 3. Okay. Now you have to find out B minus C. B minus C is equal to, so 3 minus 4 is minus 1, right? Minus 1, I think you can write one more step here. Otherwise, you'll make mistakes. So I'm writing one more step here. Okay. That is B minus C. So first element will be 3 minus 4. Second is minus 1 minus 1. Then 2 minus 2. Then 2 minus 2. Then 4 minus 0. Then 2 minus 3. 5 minus 2. 2 minus 1. 0 minus minus 2. Right. Then 3 minus 3. Okay. So what is the result? What is the result? 3 minus 4 is minus 1. Minus 1 minus 1 is minus 2. 2 minus 2, 0. Then 4 minus 0, 4. 2 minus 3, minus 1. 5 minus 2, 3. 2 minus 1, 1. And this one is 2 and this one is 0. Okay. So our matrix is minus 1, minus 2, 0. 4 minus 1, 3. 1, 2, 0. All right. Now you have to consider the LHS, right? LHS was A plus B minus C, right? A plus B minus C. Okay. So A is 1, 2, minus 3, 5, 0, 2, 1, minus 1, 1, plus B minus C is minus 1, minus 2, 0, 4, minus 1, 3, 1, 2, 0. Okay. Now you add the corresponding elements. Okay. 1 minus 1, 0. 2 minus 2, 0. Then minus 3 plus 0, that is minus 3. Right? Then 5 plus 4. 5 plus 4, 9. Then 0 minus 1 is minus 1. 2 plus 3. 2 plus 3, 5. Then 1 plus 1. Right? 2. Now what about minus 1 plus 2? It is 1. Right? Then 1 plus 0 is again 1. So it is 0, 0, minus 3, 9 minus 1, 5, and 2, 1, 1. All right. So we have got the LHS. This one is our LHS. Now what about our RHS? RHS was A plus B, A plus B minus C. A plus B minus C. And what was our A plus B? We have already found out A plus B. 4, 1, minus 1, 9, 2, 7. Then 3 minus 1, 4, minus, what was our matrix C? It is 4, 1, 2, 0, 3, 2, 1, minus 2, 3. Okay, now you have to subtract the corresponding elements. Okay, 4 minus 4 is 0, 1 minus 1, 0, minus 1 minus 2, that is minus 3, 9 minus 0, 9, 2 minus 3 is minus 1, 7 minus 2 is 5, 3 minus 1 is 2, minus 1, minus 1 minus 2, that is minus 3, right? Now what about 4 minus 3? It is 1. So what is our matrix? 0, 0, minus 3, 9 minus 1, 5, 2, minus 1 minus minus 2. Okay, here it is minus 1 minus minus 2. That is minus 1 plus 2. Right? Minus 1 plus 2 is 1. Okay, 1 and 1. So this is our RHS, right? RHS. So now we have got LHS is equal to RHS, which means A plus B minus C. From this you can conclude that A plus B minus C is nothing but A plus B minus C. Alright, now we are moving on to our third question. If A equal to matrix 1, 1, minus 1, 2, 0, 3, 3, minus 1, 2, B equal to 1, 3, 0, 2, minus 1, 4, and C equal to 1, 2, 3, minus 4, 2, 0, minus 2, 1. Find ABC, A into BC, right? Then AB into C, show that AB into C is equal to A into BC. Okay. Now here you have to find out AB. How will you find out AB? You have to multiply those two matrices. So here I'm multiplying it directly from the question. Okay. So this is the first row and this is the first column of matrix B. You have to multiply each element. So what is the result? What is the result? So first you have to multiply 1 into 1, right? 1 into 1 is 1, 1 plus 1 into 0 is 0. Then what is minus 1 into minus 1? It is plus 1. So this is our first element. Now you have to multiply the first row with the second column. Then you will get the second element. So 1 into 3, that is 3. Then 1 into 2 is 2. Then minus 1 into 4 is minus 4. Okay. So this is our second element. Okay. Now, what is the second row? That is, you have to multiply the second row with the first column, then you will get the first element of the second row, right? So here, 2 into 1, that is 2, then plus 0, then 3 into minus 1, 3 into 1, 3 into minus 1 is minus 3, then 2 into 3 is 6, then plus 0 into 2 is 0, then plus 3 into 4 is 12. Now, 3 into 1 is 3, then minus 1 into 0 is 0, right? Now, 2 into minus 1 is minus 2. Then 3 into 3 is 9. Minus 1 into 2 is minus 2. Then 2 into 4 is 8. Okay. So what is our answer? 1 plus 1, 2. 3 plus 2, 5. 5 minus 4 is 1. 2 minus 3 minus 1. 6 plus 12, 18. 3 minus 2 is 1. Then 9 minus 2, 7. 7 plus 8 is 50. Okay. So it is 2, 1 minus 1, 18, 1, 50. Now, AB into C. AB into C is equal to 2, 1 minus 1, 18, 1, 15 into 1, 2, 3 minus 4, 2, 0 minus 2, 1. Okay. So this is our first row. These are our columns. So 2 into 1 is 2 plus 1 into 2 is also 2. Right? So this is our first element. Now 2 into 2 is 4 plus 1 into 0 is 0. Okay. Now what you have to do, you have to multiply this row with this column. Okay. 2 into 3 is 6. Then 1 into minus 2 is minus 2. 2 into minus 4 is minus 8. Then 1 into 1 is 1. Then minus 1. You have to consider the second row. Okay, multiply with each column. Minus 1 into 1 is minus 1. Then 18 into 2 is 36. Then minus 2 plus 0. Then minus 3 minus 36. Then minus in 1 into minus 4 is plus 4 plus 18. Now 1 into 1 is 1 plus 15 into 2 is 30. Then 1 into 2 plus 15 into 0 is 0. 1 into 3 is 3. Then 15 into minus 2 is minus 30. 1 into minus 4 is minus 4 plus 15. Okay. So our answer is 4. Then 4. 6 minus 2 is also 4. Minus 8 plus 1 is minus 7. Right. Minus 1 plus 36 is 35. All right. Now, what about minus 2 plus 0 is minus 2. Minus 3 minus 36 is minus 39. Then, what about 4 plus 18? 4 plus 18 is 22. Then 1 plus 30, 31. 2 plus 0, 2. 3 minus 30 is minus 27. And minus 4 plus 15, right? Minus 4 plus 15 is nothing but 11. Okay. So this is our AB into C. Now you have another part also, that is you have to find out A into BC also. A into B. For that, first we need BC, right? BC is equal to. So BC is equal to matrix 1, 3, 0, 2, minus 1, 4. Okay. That into 1, 2, 1, 3, minus 4. This was 0, minus 2, and 1. Okay. So these are matrices B and C. Now you have to multiply B and C. Okay, this is our first row. These are our columns. Okay. So 1 into 1 is 1, plus 3 into 2, 6. Then 1 into 2 is 2. Then 3 into 0 is 0. 1 into 3 is 3. Minus 3 into 2, 6. 1 into minus 4 is minus 4 plus 3. Okay, 0 into 1 is 0, plus 2 into 2 is 4, then 0 plus 0, then 0 into 3 is 0, then 2 into minus 2 is minus 4, 0 into minus 4 is 0, then plus 2. Minus 1 into 1, that is equal to minus 1, plus 4 into 2 is 8, then minus 1 into 2 is minus 2, plus 4 into 0 is 0, then minus 1 into 3 is minus 3, then minus 8, then minus 1 into minus 4 is plus 4, and this is also 4. Okay, so what is our matrix? Our matrix is 1 plus 6, 7, 2, 3 minus 6 is minus 3, minus 4 plus 3 is minus 1, 0 plus 4 is 4, 0, 0 minus 4 is minus 4, 0 plus 2 is 2, and minus 1 plus 8 is 7, minus 2, minus 3 minus 8 is minus 11, and what about 4 plus 4? It is 8. Okay, so this is our matrix. 7, 2 minus 3 minus 1, 4, 0 minus 4, 2. Okay, 7 minus 2 minus 11, 8. Now what you have to do? You have to find out A into BC. You have to find out A into BC. So our matrix A was 1, 1 minus 1. Then 2, 0, 3. 3 minus 1, 2. Into BC is 7, 2 minus 3 minus 1. 4, 0 minus 4, 2. 7 minus 2 minus 11, 8. All right. So 1 into 7 is 7 plus 4 minus 7. Then 1 into 2, 2 plus 0 plus 2. Then 1 into minus 3 is minus 3 minus 4, then plus 11. Then 1 into minus 1 is minus 1 plus 2 minus 8. Okay. Then 2 into 7 is 14 plus 0 plus 21. 2 into 2 is 4 plus 0 minus 6. Then 2 into minus 3 is minus 6 plus 0 minus 33. 2 into minus 1 is minus 2 plus 0 plus 3 into 8 is 24. Then 3 into 7 is 21 minus 4, right? Minus 1 into 4 is minus 4 plus 2 into 7 is 14. Okay. Now 3 into 2 is 6 plus 0. Then what about 2 into minus 2 is minus 4. Then 3 into minus 3 is minus 3. Then plus 4. Then plus, sorry, it is minus 2 into 11, right? It is minus 22. Now 3 into minus 1, minus 3. Then minus 2. Then 8 into 2 is equal to 60. Okay. So what is the result? So here you can see it is 4. This is also 4. And minus 3 minus 4 is minus 7, right? Minus 7 plus 11. So it is 4. Then minus 1 plus 2 minus 8. Okay. So it is 1 minus 8. That is minus 7. Now the second row 14 plus 21. So it is 35. Now 4 minus 6 is minus 2, then minus 39, then minus 2 plus 24 is 22, then 21 minus 4, 21 minus 4 is 17, 17 plus 14, right? So it is 31. Okay. Now 6 minus 4 is 2. Now minus 3 plus 4 is 1. 1 minus 22 is minus 21. Then minus 3 minus 2 is minus 5 plus 16, that is equal to 11. Okay. So this is our matrix 4, 4, 4 minus 7, 35 minus 2 minus 39, 22, 31, 2 minus, is there any mistake here? Okay. Here it is 3 into minus 3. It is minus 9, right? 3 into minus 3 is minus 9. Okay. So the answer will be minus 27. Okay. So minus 9 plus 4 will be minus 5. Minus 5 minus 22 is minus 27, right? So this is our A into BC. Now, we have already found out AB into C, right? Okay. So this was our LHS. And now what we have got is our RHS. So we have got two equal matrices, right? So which means the result is true. Which result is true? AB into C is equal to A into BC. All right. Now we are moving on to our fourth question. So if matrix A is equal to 1, 0, 2, 0, 2, 1, 2, 0, 3, prove that A cube minus 6A square plus 7A plus 2I equal to 0. Okay. So here you have to find out, first you have to find out A cube. For that you need A square, right? So for that I'm finding out A square. What is this A square? A into A, right? So A is 1, 0, 2, 0, 2, 1, 2, 0, 3 into matrix A itself. 1, 0, 2, 0, 2, 1, 2, 0, 3. Okay. So these are our rows and columns. So that is equal to 1 into 1 is 1, then plus 0 plus 4, right? Then 0 plus 0 plus 0. Okay. Then 1 into 2 is 2 plus 0 plus 2 into 3 is 6, right? Now you consider the second row. What is the second row? 0 to 1. Then you multiply the second row with each columns, right? So the answer will be 0 plus 0 into 1 is 0. Again, it is 0. 1 into 2 is 2. Okay. Now, the second part is also 4 plus 0. Okay. 0 into 2 is 0 plus 2 plus 3. Now, 2 into 1 is 2 plus 0 plus 3 into 2 is 6. Then 2 plus 0 plus 0. Okay. Now, 2 into 2 is 4. 4 plus 0 plus 3 into 3 is 9. Now, what is the matrix? It is 5, 0, 8, 2, 4, 5. 2 plus 6 is 8. Then 2, 4 plus 9 is 30. Right? So our matrix A square is 508, 245, then 8. Is there any mistake in the second row? It's actually 2 into 0 is 0, right? 2 into 0 is 0. Okay, so the second element is completely 0, 8, 0, 30. Okay, now you have to find out A cube. How will you find out A cube? We have got A square, right? So A cube can be written as A square into A, right? We have got A square. A square is 508, 245, 8030 into A is 102, 021, 203. Okay, these are our matrices. Again, you do the matrix multiplication. Okay, so if you do the matrix multiplication, 5 into 1 is 5 plus 0 plus 8 into 2 is 16, right? Then 5 into 0 is 0 plus 0, again 0. Okay, then 5 into 2, third column. Okay, 5 into 2 is 10 plus 0 plus 8 into 3 is 24. Now, consider the second row. 2 into 1 is 2 plus 4 into 0 is 0 plus 5 into 2 is 10, right? Now, second column, 2 into 0 is 0 plus 4 into 2 is 8 plus 5 into 0 is 0. Okay, then 2 into 2 is 4 plus 4 plus 5 into 3 is 15. Now 8, 0, 13. 8 into 1 is 8 plus 0 plus 13 into 2 is 26. Then 0 plus 0 plus 0. Okay, now 8 into 2 is 16 plus 0 plus 13 into 3 is equal to 39. Alright, so what is the result here? 5 plus 16, 21, 0, 34. Then 12, 8, then 4 plus 4 is 8, right? 8 plus 15, it is 23. Now 8 plus 26, 26 plus 4, 30, 34, right? 0, then this one is 55, right? 16 plus 39 is 55. So matrix is 21, 0, 34, 12, 8, 23, 34, 0, 55. So this is our matrix A cube, right? Now what you have to do, you have to, the question was prove that A cube minus 6A square plus 7A plus 2I is equal to 0. What is the 0? 0 is nothing but the 0 matrix. Alright, it is the 0 matrix itself. So you have to verify that result, right? So, or that equation. So how will you verify? You have to substitute all these results in that equation and you check whether that you are getting a 0 matrix or not. If you are getting a 0 matrix, then it is true. Since here in the question it is prove that, which means the result is true. You have to just apply the find all these matrices and just put in that equation and then you will get the 0 matrix. All right. So here our equation, first I'm writing that equation, A cube minus 6A square plus 7A plus 2I equal to 0. All right. So A cube was 21, 0, 34, 12, 8, 23, 34, 0, 55. Minus 6 into A square is 508, 245, 8013. Okay. And 7 into A, right? 7 into matrix A is 021, 203. All right. Plus 2 into I. What is this I? I is nothing but the identity matrix. Identity here, you can say that in that equation, everything is a 3 by 3 matrix. So you consider I identity matrix a 3 by 3 matrix itself, right? So this will be 1, 0, 0, 0, 1, 0, 0, 0, 1. So what is the peculiarity of an identity matrix? All the diagonal elements will be 1 and the non-diagonal elements will be 0. Okay, now you have to check that if you do this particular operation or if A satisfies this particular equation, with the result, if the result is a 0 matrix, then we can say that it is true. Okay, so first you have to solve this one, right? For that, you have to multiply these scalar numbers with this matrix. How will you multiply scalar numbers with a matrix? You have to multiply each elements with that scalar number. Huh? Isn't it? So first you have to multiply 6 with each elements in the matrix. Okay. So this will become 21, 0, 34, 12, 8, 23, 34, 0, 55 minus, here you can see that 6 into 5 is 30, 6 into 0 is 0, 6 into 8 is 48. Similarly, you have to multiply each element with 6. Okay, so I am writing that matrix here. So the matrix will be 30, 0, 48, then 12, 24, 30, 48, 0, 78. Okay, so these are the elements which are obtained by multiplying 6 with a square. 6 with the matrix a square. Okay, now you have to multiply 7 with the matrix A. Right, 7 with the matrix A. So the matrix obtained will be 7, 0, 14, then 0, 14, 7, then 14, 0, 21. Okay, plus 2 into identity matrix is 2, 0, 0, 0, 2, 0, then 0, 0, 2. Okay, so that is equal to, how will you do this operation? Here, 21 minus 30 is minus 9. Minus 9 plus 7. Okay, minus 9 plus 7 means minus 2. Minus 2 plus 2 means 0. So the first element is nothing but 0. Okay, similarly, you have to do each elements. Okay, the operations with each element. So 0 minus 0 is 0. Then again, all the elements in the second question is 0. So the total result is also 0. 34 minus 48, right? This is equal to minus 14. Minus 14 plus 14. Minus 14 plus 14 is equal to 0. Okay. Now, here you can see it is okay. Here you can see 12. 12 minus 12 is 0. Then 0 plus 0 is also 0. So the total is 0, right? So this is 0. Now again, 8 minus 24 is minus 16. Then minus 16 plus 14 is, so it is minus 2. Minus 2 plus 2 is 0. So this one is also 0. Next one, 23. 23 minus 30 is minus 7. Plus 7 is 0. Then addition will give you 0. Okay. So this is 34. 34 minus 48. Right. It is minus 14. Minus 14 plus 14 is 0. Then 0. Next element is completely 0. So the result is also 0. Then 55 minus 78 is minus 23. Minus 23 plus 21. It is minus 2 plus 2 is equal to 0. All right. So we have got a zero matrix, right? A 3 by 3 zero matrix, which means the verification is done. Isn't it? We have found out that a cube minus 6a square plus 7a plus 2i equal to 0. All right. Now, fifth question. Let A equal to matrix 2 minus 1, 3, 4. Okay. B equal to 5, 2, 7, 4. C equal to 2, 5, 3, 8. Find A matrix D such that CD minus AB equal to 0. Okay, you have to find a matrix D such that CD minus AB is equal to 0. Okay, So here you have given matrix A, B and C, but C is unknown. You have to find C from that particular equation given. All right. So that is here A into B, AB. Okay, AB is 2 minus 1, 3, 4 into 5, 2, 7, 4. 5, 2, 7, 4. Okay. So that is equal to 2 into 5 is 10, 10 minus 7. Okay, 2 into 2 is 4, 4 minus 1 into 4 is 4. Then 3 into 5 is 15 plus 4 into 7 is 28. Then 3 into 2 is 6 plus 4 into 4 is 16. So 10 minus 6 is 3, 4 minus 4 is 0, then 15 plus 20, right? So that is 35, 33, right? 33. Then, I'm sorry, it is 43. Then 16, it is 22, 6 plus 16, right? So our matrix is 3, 0, 43, 22. This is our matrix AB. Okay. Now what is our equation? It was C into D minus this matrix, right? 3, 0, AB. Okay. CD minus AB equal to 0. So this is our AB, right? So 43, 22, that is equal to 0. Okay. So CD is equal to what is the 0? 0 is the identity. 2 by 2, 0 matrix. Okay. So which means CD is equal to 0, 0, 0, 0 plus our matrix AB. That is 3, 0, 43, 22. Okay, here you can see that we are adding two 2 by 2 matrices. Okay, so the result will also be a 2 by 2 matrix, right? If you add 2, that is you get the result, right? 0 plus 3 is 3, 0. Then this one is 43 and this one is 22. Okay, if you add this, it is a 2 by 2 matrix. Okay, 3, 0, 43, 22 means it is a 2 by 2 matrix. Okay, which means order of matrix CD is equal to 2 by 2. And what is the C? C is given, right? C was 2, 5, 3, 8. Then D is unknown. That is equal to 3, 0, 43, 22. 3, 0, 43, 22. All right. Now from this you have to find out D. So what will be the order of D? From this can you find out the order of matrix D? What will be the order? Here you can see that it is a 2 by 2 matrix and this is also a 2 by 2 matrix, right? So you are multiplying a 2 by 2 matrix with some matrix and you are getting a 2 by 2 matrix. Okay, which means if you know that matrix multiplication is only possible when the number of columns of first matrix is equal to number of rows of the second matrix, right? Number of columns of first matrix should be equal to number of rows of second matrix, right? So what is the number of columns of the first matrix? It is 2, which means what is the number of columns of D? Number of columns of D, that is equal to 2, right? And here you are getting a 2 by 2 matrix, isn't it? So what is the order of a matrix multiplication? What is the order of how you find out a order of matrix? If order of A, matrix A is 1 by 2, then order of B should start with 2, right? Then it can be any other number. If it is 3, then what is the order of AB? Matrix AB will be 1 by 3, right? 1 by 3. Here you can see that it is 2 by 2, which means the number of columns of D matrix is 2, right? Then only here the order will come as 2, right? So number of columns is 2 and number of rows should be equal to 2. Then only the matrix multiplication is possible. So we have got the order of matrix D as a 2 by 2 matrix, right? So we understood that D is a 2 by 2 matrix. So how will you generally represent a 2 by 2 matrix? We can use elements A, B, C, D. Okay, since the elements of the matrix D are unknown, we are just assuming the numbers be A, B, C, D. Okay, so the matrix C is 2, 5, 3, 8 into A, B, C, D. A, B, C, D. That is equal to 3, 0, 43, 22. Okay, so this is equal to, you have to multiply that side, then only you will get the element. So 2a plus 5c, then 2b plus 5d, then 3a plus 8c. Right? Now what about this 3b plus 8d? Right? So this is equal to 304322. Okay. So which implies 2a plus 5c is equal to 3. Okay. And 3a plus 8c is equal to 43. Alright. From this you will also get 2b plus 5d. Two matrices are equal only if their corresponding elements are equal, right? So these are the corresponding elements. So we can equate that one, right? So this means 2b plus 5d equal to 0. And 3b plus 8d is equal to 22. Now you have to solve these equations and you will get the values for A and C. Okay, how you solve equations? Here you can see that this 2a and 3a can be made equal, right? How can you make these equations equal? By multiplying it with first equation with 3 and then this equation with 2. Okay, so you'll get it as, we can write it in the another page. Okay, so this will be 3 into 2a, that is 6a, plus 3 into 5c is 15c is equal to 3 into 3, 9. Similarly, 2 into 3a is equal to 6a, plus 2 into 8c is equal to 16c. Then 2 into 43 is equal to 86. Okay, so this will become 6a plus 15c is equal to 9. Okay, the second equation becomes 6a plus 16c is equal to 86. So this is our first equation and this is our second equation. Okay, so 2 minus 1. 2 minus 1 implies 6a minus 6a is 0, right? 16c minus 15c is c. C is equal to 86 minus 9, that is equal to 77. So we have got the value for c, it is 77. Now you can find the value of a from that, right? You can use any of the equations. So I'm taking 2a plus 5c is equal to 3 and I'm substituting the value of c in that particular equation, that is 5 into 77 is equal to 3. 2a plus 385 equal to 3, which means 2a is equal to 385 minus 3 minus 385, right? 3 minus 385. So 2a equal to minus 382 and the value of a is minus 382 by 2, that is equal to minus 1, then 89 minus 191, minus 191. Okay, now the second one is 2b plus 5d equal to 0, 3b plus 8d equal to 22. Okay, so this into 3 and this into 2. We can make these 2b and 3b as equal, right? So this is how you solve equations. So the first equation will become 6b plus 5d into 3, that is 15d equal to 0. The second equation becomes 6b plus 8 into 2, 16d is equal to 44. Then now you subtract 1 from 2, 2 minus 1. 2 minus 1 means D is equal to 44. You have got the value of D. Now, 2B plus 5D equal to 0. So, 2B plus 5 into 44 equal to 0. So, 2B plus 5 fours are 20. So, 2, then 22, that is equal to 0. So, 2B equal to minus 220, right? So, what is the value of B? Minus 220 by 2, that is equal to minus 110. Minus 110. Now, we have got the value for B. From that, you can get the value of D also. So, consider 2B plus 5D equal to 0, right? So, okay. Here we have got the value of D. Now we have got the value of B also, right? So we have got all the values, right? A, B, C, D. So can you write the matrix D? We have got all the 4 elements of the matrix D. Now we can write matrix D. What is matrix D? Our first element was A. A is minus 191. Then B is minus 110. Then C was 77 and D was 44. Okay. So this is our 2 by 2 matrix D. Okay. Now, moving on to our 6th question. If matrix A is equal to 0 minus tan alpha by 2, tan alpha by 2, 0, and I is the identity matrix, I is the identity matrix of order 2, show that I plus A equal to I minus A into cos alpha minus sin alpha cos alpha. All right. So first we can find LHS. Okay, this is what we have to show. I plus A is equal to, what is this I? I is the identity matrix and they have given that it is of order 2 by 2 and we have to show this result is true. All right, so first you can consider the LHS, right? What is LHS? Identity matrix plus the given matrix A, right? So I plus A is equal to 1 0 0 1 plus 0 minus tan alpha by 2, tan alpha by 2, 0. So that is equal to 1 plus 0 is 1. 0 plus minus tan alpha by 2 is minus tan alpha by 2. Then 0 plus tan alpha by 2 is tan alpha by 2. Then 1 plus 0 is 1. So that is I plus A. Okay, now what you have to do, what you have to find out the RHS of the equation. For that, first you need I minus A. I minus A. So again, I is our identity matrix 2 by 2 minus the given matrix A minus tan alpha by 2, tan alpha by 2, 0. Okay, so that is equal to 1 minus 0 is 1. Then minus 0 minus tan alpha by 2. So it will become plus tan alpha by 2. Then 0 minus tan alpha by 2 is minus tan alpha by 2. 1 minus 0 is 1. Okay, so this is our I minus A. Now what you have to do, RHS means I minus A into cos alpha minus sin alpha, then sin alpha cos alpha. Okay, so this is equal to I minus A is 1 tan alpha by 2 minus tan alpha by 2, 1 into cos alpha minus sin alpha cos alpha. Okay, so again we have to multiply these. So the first one will be 1 into cos alpha, then tan alpha by 2 into sin alpha, that is cos alpha plus sin alpha into tan alpha by 2. Okay, likewise you have to multiply. So that is cos alpha plus sin alpha tan alpha by 2. Then the second column, right? So minus sine alpha plus cos alpha tan alpha by 2, right? This is our second element. Then this one with the first column. So minus cos alpha tan alpha by 2 plus sine alpha. Then minus tan alpha into minus sine alpha is tan alpha by 2 sine alpha, isn't it? Then 1 into cos alpha is cos alpha. Okay, so these are our 4 elements. Okay, so here you have to do substitution. That is, you have to use trigonometric identity in order to solve this particular thing. All right, that is, you have to substitute values for cos alpha and sine alpha. So we are using the identity. We know cos 2 theta is equal to 1 minus tan square theta by 1 plus tan square theta. Similarly, sine 2 theta is equal to 2 tan theta divided by 1 plus tan square theta. Okay, so this is cos 2. Here it is, instead of 2 theta, it is half angle, just cos alpha only. Okay, it is not cos 2 alpha, which means you have to make this angle also half, right? So which means the result will be 1 minus tan square alpha by 2 divided by 1 plus tan square alpha by 2. I hope this is clear to you all. Here it is 2 theta. So yeah, here we are taking half of that angle. Here it is only alpha. So here also you have to take half of that particular angle. So it will be alpha by 2. Okay. Now what about sine alpha? Here also you should take the half of that angle. Right. So this will be 2 tan alpha by 2 divided by 1 plus tan square alpha by 2. Okay. Now the first element is cos alpha plus sin alpha tan alpha by 2. So this is the first element of our matrix. Okay. So this is equal to, what is cos alpha? Now I'm going to substitute this particular identity. Okay, cos alpha is 1 minus tan square alpha by 2 divided by 1 plus tan square alpha by 2 plus, what is sin alpha? Sin alpha is 2 tan alpha by 2 by 1 plus tan square alpha by 2. Okay, into tan alpha by by 2. Okay, here you can see that this one can be multiplied, right? This one can be multiplied, and you can see that the denominator is common. So I am taking that denominator as common. 1 plus tan square alpha by 2. Then this can be written as 1 minus tan square alpha by 2 plus 2 tan alpha by 2 into tan alpha by 2 will become 2 tan square alpha by 2. Okay, which means minus tan square alpha by 2 and plus 2 tan square alpha by 2. What is the result? 1 minus, here there is a 1, right? So 1 plus, right? 1 plus tan square alpha by 2 divided by 1 plus tan square alpha by 2. What is the value? It is 1. All right. Similarly, you have to find out the second, third, and fourth element by using the identities. Okay. So the second element was minus sine alpha plus cos alpha tan alpha by 2. Again, you have to simplify this using the identities for sine alpha and cos alpha. So this will become minus 2 tan alpha by 2 by 1 plus tan square alpha by 2. Right? 1 plus tan square alpha by 2. What is cos alpha? 1 minus tan square alpha by 2 by 1 plus tan square alpha by 2 into tan alpha by 2. Isn't it? So this will become, here also you can see that 1 plus tan square alpha by 2 is common, right? So here you have to multiply tan alpha by 2 with 1 as well as minus tan square alpha by 2. So this will become minus 2 tan alpha by 2 plus the numerator is 1 minus tan square alpha by 2 into tan alpha by 2, right? And the denominator is common. It is 1 plus tan square alpha by 2. So minus 2 tan alpha by 2 plus, it will be like this. Okay. So that is tan alpha by 2, then minus tan cube alpha by 2 by 1 plus tan square alpha by 2. So that is equal to minus 2 tan alpha plus tan alpha will become minus tan alpha by 2 minus tan cube alpha by 2 divided by 1 plus tan square alpha by 2. Here you can take tan alpha by 2 outside, right? So this will become, I'm writing here. Okay. So if I take tan alpha by 2 outside, minus tan alpha by 2 can be taken outside, right? So this will become 1 plus tan square 1 plus tan square alpha by 2 divided by 1 plus tan square alpha by 2. Right? So these two gets cancelled. So the result is minus tan alpha by 2. So we have got the second element also. It is nothing but minus tan alpha by 2. Now we are moving on to the third element. The third element. Okay. So the third element was minus tan alpha by 2 cos alpha plus sin alpha. Okay, so that is equal to minus tan alpha by 2 can be written like that itself. And cos alpha you have, you know the identity, right? What is the identity? It is 1 minus tan square alpha by 2 divided by 1 plus tan square alpha by 2, right? Plus, what is sin alpha? It is 2 tan square. It is 2 tan alpha by 2, right? 2 tan alpha by 2 by 1 plus tan square alpha by 2. Okay, here also you can multiply this minus tan alpha by 2 inwards, right? So this will become minus tan alpha by 2 plus tan cube alpha by 2 plus 2 tan alpha by 2. And here you can see denominators are common. So this is 1 plus tan square alpha by 2. Okay. So minus tan alpha by 2 and plus 2 tan alpha by 2, which means it is not they're getting cancelled. The answer is tan alpha by 2. Right. 2 minus 1 is 1. Right. So it is tan alpha by 2. So tan alpha by 2 plus tan cube alpha by 2 by 1 plus tan square alpha by 2. Okay, here I can take this tan alpha by 2 outside since it is common, right? Tan alpha by 2 into 1 plus tan square alpha by 2 divided by 1 plus tan square alpha by 2. So these are common. So the answer is tan alpha by 2. So this is our third element. This is our third element. Okay. Now what about our fourth one? Tan alpha by 2 into sin alpha plus cos. I'm sorry. Okay, sin alpha is 2 tan alpha by 2 divided by 1 plus tan square alpha by 2 plus cos alpha is 1 minus tan square alpha by 2 divided by 1 plus tan square alpha by 2. That is equal to 2 tan square alpha by 2 plus 1 minus tan square alpha by 2 divided by 1 plus tan square alpha by 2. Okay, so that is equal to 2 tan square minus tan square is tan square alpha by 2 plus 1 divided by 1 plus tan square alpha by 2. Both are same, right? So the value is 1. Now we have got the 4 elements of that matrix. What was that? The first one was 1. Then second was minus tan alpha by 2. Third was tan alpha by 2. And this was 1. And what is this? This was I minus A into that matrix. That is cos alpha minus sin alpha, and cos alpha. Okay. And this was our LHS, right? This was our LHS, and now we have got the same result for RHS also. So we have proved that I plus A is equal to I minus A into this matrix, right? Okay. Now we are moving on to the last question of the session. Most probably you will have a question of verification. Okay, verification of any result that you have studied in this chapter for 5-mark session. All right. So the last question is also like that. If A is equal to 1, 2, 2, 1, B is equal to 2, 0, 1, 3, and C is equal to 1, 1, 2, 3. 1, 1, 2, 3. So calculate AC, BC, and A plus B into C. Also verify that A plus B into C is equal to AC plus BC. Alright. So first we can find out, just a minute. We can find out A plus B. So A plus B is equal to 1 plus 2 is 3, 2 plus 0 is 2, then 2 plus 1, 3, 1 plus 3 is 4. A plus B. Okay, so A plus B into C. A plus B into C. Okay, so A plus B into C. That is equal to 3, 2, 3, 4 into 1, 1, 2, 3. So this one will be this. Okay, so that is equal to 3 plus 2 into 2 is 4. Then 3 plus 2 into 3 is 6, isn't it? Now second row with first column, that is 3 plus 4 into 2, 8. Then 3 plus 4 into 3 is 12. Okay, so 7, 9, then 11, then this one is 50. 7, 9, 11, 50. Okay, this one is A plus B into C. Now you have got LHS. Now we can find out RHS also. What is this RHS? RHS is AC plus BC, right? AC plus BC. So for that you need AC, right? A into C. What is A into C? A into C means it is 1, 2, 2, 1 into 1, 1, 2, 3. 1, 1, 2, 3. Okay. So this is equal to 1 into 1 plus 2 into 2, 4. Then 1 plus 2 into 3 is 6. Then 2 plus 1 into 2 is 2. Then 2 into 1 is 2 plus 1 into 3 is 3. All right. So the answer is 5, 7, 4, 5. Okay. So we have got AC. Now we need BC also. So B is 2013 into C is 1123. Okay. So it is 2 plus 0, right? Then 2 into 1 is 2 plus 0. Then this one is 1 into 2 is 2 plus, I'm sorry, 1 into 1 is 1 plus 3 into 2 is 6. Then 1 into 1 is 1 plus 3 into 3 is 9. So this is 2, 2, 7, 10. Okay, so we have got AC, and then BC. Now you need to find out AC plus BC. You have to have these two matrices, right? So 5 plus 2 is 7. 7 plus 2, 9. 4 plus 7, right? It is 11. Then 5 plus 10 is 15. So AC plus BC is 7, 9, 11, 15. And what about A plus B into C? It is also 7, 9, 11, 15. So which means LHS is equal to RHS. LHS is equal to RHS, right? So we have proved A plus B into C is equal to, what we have proved, A plus B into C is equal to AC plus BC. Okay. So we have completed the important questions that are commonly asked in the 5-mark session. I hope this session was very useful to you all. Thank you.